Our solar system is a wondrous place with a single star, our sun, and everything that orbits around it: planets, moons, asteroids, and comets. What do we know about this beautiful solar system we call home? It's part of an even larger cosmos with billions of other solar systems.
Hi, I'm Jim Green, Director of Planetary Science at NASA, and this is Gravity Assist. I'm here with Alan Stern, the principal investigator of the New Horizons mission, and it's all about Pluto today. You know, what an amazing body that has turned out to be. You know, just a matter of a few years ago, we knew virtually nothing about Pluto. But in July 2015, New Horizons changed all that and changed everything in our lives in planetary science. You know, what really surprised me is what we found. What was your biggest surprises, Alan?
You know, I think my two biggest surprises were first, just how utterly amazing Pluto turned out to be. How many different kinds of features were on the surface and even in the atmosphere. There was something for everyone. And the second amazing finding was how many people really wanted to participate in it, in the public, and just be a part of this exploration. We expected it would be a big response, but it was much bigger than we thought. And even for months, I would say at least a year afterwards, there was this completely unparalleled public reaction that our team members would go places. We were getting requests for literally hundreds of public presentations.
Yeah.
We just couldn't fulfill it all.
I think some of that's still going on. I mean, you know, when I was in Japan, just this last week, I went to a girls' school and they wanted to know about Pluto.
Yeah.
Yeah.
Wow, that's cool.
It really is. I mean, you're right. It's just absolutely gone international. What really shocked me, actually, was the heart feature, but also the context around it. You know, few craters. It's, you know, a body smaller than the moon, and yet it looked nothing like our moon. So different.
No, Pluto has its own personality, and the heart is probably one of the biggest parts of that. You know, we named that heart Tombaugh Regio after the discoverer of Pluto, Clyde Tombaugh. When we were far away and first training our cameras on the planet in the distance, we were 100 million miles away, as far as the Earth to the sun. And every time that part of Pluto would come into view, we could see this bright, massive feature on the surface. And as it got closer and closer, it started to take this heart shape. And we decided to run with that and call it Pluto's heart. And it really does look like a heart.
Really
But what it is a massive glacier made of nitrogen ice that's 1 million square kilometers in scale. It's the size of Texas and Oklahoma combined, and the glacier is flowing. We see places where there are avalanches onto it and where it runs up against the mountains and subducts under them, and we see where it's overturning, and there's not a single crater we can find there, which means this massive piece of real estate was born yesterday geologically. It's amazing.
Yeah, it really is amazing. The other thing that I really liked about the heart that you guys have found out is it's a planitia. That means it is a lower area. And so that's led you to some really neat ideas as to how that came about.
Yeah, you know, the whole planitia is surrounded by soaring mountains that are 4 or 5 kilometers tall as the Rockies. And it looks like they were uplifted in a gigantic impact onto the surface of Pluto that formed a big basin, as I said, about 1 million square kilometers in scale, 1,000 kilometers in every direction, that dug this big hole out. And then that hole became a coal trap for snows. Primarily the atmosphere is made of nitrogen, so that's what snows the most. And it's filled up over time, just like you'd be filling up a bathtub. But our mathematical models show that as Pluto goes around its orbit, and then as it has these longer seasonal cycles, the amount of nitrogen in the basin can actually ebb and flow back and forth thousands of times over billions of years, where this, if you will, the sea level of the nitrogen, of course it's frozen, but the sea level can rise and fall by thousands of feet.
Well, is that due to its interaction with the atmosphere?
Yeah, as the sunlight, the amount of sunlight on its surface changes with either where Pluto is in its elliptical orbit or how its pole is tilted over time. As that varies, you get more or less heating into the basin, and that can either drive condensation flow in to fill it up, or what's called a sublimation, kind of an evaporation process that can draw it down.
Well, the haze on Pluto was really fantastic, and it's really quite structured. So that also just blew me away, that such a beautifully small body has such a beautiful atmosphere associated with it. And when I mean small, I mean it's just smaller than the moon, but yet it's so dynamic. It's got almost everything a planet ever wanted to have.
Yeah, I think it shows that small planets can be as interesting as big planets.
Yeah.
We expected that haze for decades. There were hints of it in ground-based data, and you look at artists' conceptions of Pluto, and they'll often show a low-lying kind of haze layer towards the surface. But what we found was this soaring structure with dozens of layers that stretch up literally 500,000 feet into Pluto's sky. And when we took color pictures of it, it's blue. So there aren't many places with blue skies. Earth is one of them. Pluto's another. And that, along with the structure and all the fine layering in the haze, really caught us by surprise.
Well, I think the blue light is being backlit. But what's happening in the atmosphere is quite a chemical reaction going on, interacting with the solar wind, but also with the UV light. And then complex carbon molecules are coming together and creating what are called the tholins. So that's my understanding of what's happening. And those are red.
Yeah, that's spot on. And that's what is probably silting out onto the surface of Pluto and making the surface red. The reason the atmosphere, the Earth's atmosphere is blue, but the air isn't blue, it's that the scattering properties of the molecules create a blueness through a process called Rayleigh scattering that Lord Rayleigh figured out almost 200 years ago as an early atmospheric scientist and physicist. In Pluto's,
lets the red through, but the blue wavelengths get scattered.
They get scattered much more efficiently,
right. Mm-hmm.
And so the red passes through, and the blue is what gets scattered around and sort of paints the color of the atmosphere, if you will. Even though the air itself is colorless, the actual molecules, and the same is true in a body of water. The same kind of process makes the ocean blue or a swimming pool blue. In Pluto's case, it's different. It's the fine suspended particles, which themselves, even though they are red, the way they interact with sunlight through a different process discovered by a different physicist called Mie scattering, generates the blue color. And as you say, it's a primarily forward scattering effect. So you see it from the far side of Pluto looking back when sunlight is filtering through the atmosphere. But if you were an astronaut and you were there, it would literally appear blue, just like the Earth's atmosphere.
What I really like, too, is the analogy of standing in some places on Pluto, and it's snowing red.
It's red snow.
Red snow.
Yeah,
wow.
That's a sci-fi planet for you.
Yeah, it really is. Yeah, that's fantastic. You'd been thinking about going to Pluto for quite a while, and you were, I have to admit, the driving force that really made that happen.
Well, a lot of people worked on it.
Well, I know, but I don't know we'd be there without you. I gotta tell you that right now. But I'm sure you'd say it's all worth it. But it takes quite a toll, because it takes an enormous amount of energy and an enormous amount of concentration to pull off.
It does, and it took a toll on our families. I think for many of us, we signed up for nights and weekends and long hours and lots of travel. And for kids and partners and spouses and relatives, you're absentee a lot, but I think it was well worth it. And I wouldn't trade it. I would do it again in a minute. I think we really did something good for science, and we did something good for exploration, and we inspired a lot of people. And you can't help but be proud of that.
Yeah, well, you did something for the nation and NASA. That's for sure. It's so exciting. There's the thinking now, I believe, has started that will end up in this next decadal. We have our decadals that come out by the National Academy in terms of what are the next steps. where some considerations got to be made about going back to Pluto and Charon. What's your thoughts on that? How can we possibly pull that off?
Well, I think we know how to do it from a technology standpoint, and there's studies going on where I work at the Southwest Research Institute that are funded by internal research funds to get a head start on that, at Goddard Space Flight Center, at Ball Aerospace, and some other places. NIAC is doing some studies. And it's clear that we have the technology to put an orbiter around Pluto and even to fly it there about as fast or maybe even faster with the SLS than you could go with New Horizons. And the interesting thing is that we've learned from these studies that the big satellite Charon can play the same role at Pluto that Titan did for Cassini. It's your motorboat that lets you tour the system by gravity assists. So you can visit all the small satellites and go out in the tail, the plasma tail, and dip down into the atmosphere with a mass spec and do all these things virtually for free in terms of fuel, because Charon is giving you gravity assist after gravity assist after gravity assist.
Well, I really like that concept already, I can tell you that. But Charon also is pretty spectacular. It's very different than Pluto in terms of its color and a variety of features. What did you guys think about that when you saw it?
Well, we knew the two would be different. From all the ground-based data, we could see that Pluto had more personality, if you will. It had brighter colors and more reflective surface and much more varied bright and dark areas as it rotates. But Charon's got its own personality, and it's got some really unique features that we don't see anywhere else in the solar system. This vast canyon across the equator that stretches for more than 1,000 miles is probably the result of the freezing of an interior ocean early after its formation, as it went from a hot interior, liquid, to a solid, cooled-off interior. And it's got this tremendous science fiction polar cap, which is this big red polar cap, like something somebody would dream up, not that would actually happen. And it turns out the polar cap is made of stuff from Pluto that's flowing across space in between them and sticking to Charon's surface at the poles where it's coldest and turning red for the same reason those tholins in the surface of Pluto are red. So Charon's got a lot to teach us as well.
In addition to Charon, Pluto's got some other spectacular moons. And they're spinning, and they're not all tidally locked, which was also quite a surprise. What's that all about?
Well, if I knew, I would go out and write a paper. So we sort of understand the problem. That's the first thing is, first you have to admit there's a problem, and then you can start to cope with it. Really, we expected the small satellites would tidally spin down and behave like normal satellites of a giant planet. But it looks like the Pluto-Charon binary, being a binary and being so unusual in that it's got a lumpy gravitational field because you've got two masses there, create these kicks and bumps as the small satellites orbit that keep working against the tidal forces that would damp down their rotational periods. Instead, it excites them. It gives them kicks. And you've got, take Hydra. Hydra's the farthest out, and it's tumbling almost 100 times for every time it rolls around Pluto once in its orbit. It's like a football that's just tumbling and tumbling and tumbling every 10 hours.
When I first saw that, I thought, well, this must have been some sort of recent impact that has done that, and it's just indeed hasn't quite slowed down. But then when many of the other moons also didn't show that tidally locked position, then you're right. Something else has to explain that.
Yeah, and a lot of people thought what you just said, that it must be evidence for a recent impact. And yet, as you say, because all four are doing it, that's too improbable. But also, some people thought that maybe the system had just formed. But when our crater counters did the work to determine the surface ages, because the more craters, the longer it's been out in the rain of impactors. They got an age of billions of years old for those small satellites, just as old as Charon, which meant that they were all formed together and very, very long ago. And something else is going on to make those unusual spin rates.
Well, the other part to that, too, is doesn't look like there's any debris laying around. So if there was a recent impact, where'd all the debris go?
Exactly. The system's clean as a whistle.
Yeah.
Yeah, I lost a bet on that.
Well, one of the things that I always like to do with my guests is really talk about how they got into that field, how they really got excited about what they're doing, and the drive that they obtained. So, Alan, what was your gravity assist that made that happen for you?
Gosh, there are probably a lot, but one that comes to mind right away is my dad, who was not in the space business, not in the science business. He was in sales and management. And one day he came home from a business trip with his little handheld voice recorder, and he said, "Guess who I sat next to on this airplane? Apollo astronaut Wally Schirra. And he left a message for you." And then my dad played this, and there was Wally Schirra, and pretty much saying, "Hey, Alan, I understand you live in Dallas and you're interested in science and you study hard and, you can do anything you want. You can come be an astronaut like I am, or be a scientist or an engineer or whatever you want to work on. Go get them. I hope I meet you someday." And wow, for a 9 or 10-year-old kid, boy, that was a gravity assist.
No kidding. That sounds fantastic.
It's true.
Yeah. Did you ever get back and meet Wally?
I never did meet him. I've met quite a number of the Apollo astronauts, but I don't know if the tape still works, but I know we still have that little handheld recorder. I wouldn't let my dad throw it away. I'm sure it's in my parents' attic somewhere.
New Horizons now, past Pluto, fine style, and now it's pointing out into the Kuiper Belt. What's next for it?
Well, the best kept secret about New Horizons is we're using the telescopes on board as an observatory, actually in the Kuiper Belt. We just woke the spacecraft up in September and all the way through the end of the year. It's observing small planets and even smaller Kuiper Belt objects across our trajectory. And then the end of 2018, we're bearing down on our next flyby, 1 billion miles beyond Pluto, of one of the building blocks of these planets like Pluto. It's an object that doesn't have a name yet, just a license plate, 2014 MU69. But it's probably the most pristine relic of the formation of the solar system ever to be explored. It's been out in that 400 degrees below zero deep freeze for 4 billion years, and we've never been to anything like that before. We don't quite know what to expect. It's a little bit like Pluto in that regard. I'm sure we'll see some surprises. And it all happens at the holidays in 2018. So you can spend your Christmas in the Kuiper Belt and your New Year's Eve with NASA. The flyby is actually on New Year's Eve and New Year's Day, turning 2019. And New Horizons is in spectacularly healthy shape and ready to go back in the ring for the next round.
Well, I know where I'll be during that time period. That's for darn sure. Well, it's been just a delight to chat with you, but I got to tell you, we're going to have you back. Our next podcast, we want to talk about the Kuiper Belt, going well beyond Pluto and into the solar system deeper and deeper. Join us next time as we continue our virtual tour of the solar system. I'm Jim Green, and this is your Gravity Assist.